Okay. So, we have discussed about the single tube model. Now, if you see the speech production system of human being, so red color mark is the tube vocal tract. So, this is the whole vocal tract is like that. If you see the cross sectional area of the vocal tract is not uniform throughout the tube. Here cross sectional area very small. So, whatever the constriction is made, the cross sectional area of the tube along the, you can say the x equal to 0 to x equal to L at the lips, the tube cross sectional area is not uniform. Okay. So, instead of a single uniform tube with a fixed cross sectional area, which is A, we have done. Instead of that, now we want to make the model with a multiple tube of different cross sectional area connected to each other. So, if I see let us this kind of things, that this is the glottis and this is the lips, this is the structure of my vocal tract. Now, I can say whole vocal tract, instead of modeling by a single uniform tube, can be modeled as a multiple number of uniform tube connected with each other. So, let us the whole tract is modeled by a n number of tube with a fixed length is fixed, let us the length is L. So, I can say let us LK length tube and n number of tube is connected with each other. So, I can say the vocal tract is modeled like this way. So, I can say L1, or initially I can say that okay, whole vocal tract can be modeled different number of connected tube or different length also. So, if I say that we will do that, then I can say this is the L1, L2, L3, L4, L5 number of this is the length of the tube and 5 number of tube is connected to each other. Or I can consider L1 equal to L2 equal to L3 equal to L4 equal to L5, then the length of the tubes are same, but n number of small tube I divided and whose cross sectional area is A1, A2, A3, A4, A5 all are not same, different cross sectional area. Now, if I consider that, then what is the problem? If I consider that the whole tube is a connected tube instead of a single tube. So, the problem is that I know what will happen when a sound will travel throughout the tube. Okay, if it is a single tube, I know input and output. It is in the tube acts as nothing but a delay. I can derive the equation for signal flow equation from input and output and can find out the transfer function of the tube. There will be an effect at junction also. So, the main purpose for multiple tube modeling is that I have to find out what happening at each and every junction of the tube. So, the cross section, this one is very small cross sectional area, this is wide cross sectional area. So, what will happen volume velocity and pressure wave equation in this junction? What will happen while tube will be connected here this junction? So, I want to know what will happen at kth junction. So, kth junction is nothing but a kth tube and kth plus 1 tube junction. That junction I want to know what will happen. So, instead of single tube, let us consider I have a tube, the different tube are connected with each other with different cross sectional area. So, let the kth junction I have taken. So, this is the kth junction of the tube. So, this is the k plus 1 tube and this is the kth tube, this is the junction. So, here if it is LK, then here if I say this is the beginning of the kth tube, so x equal to 0 and here it is x equal to LK. Okay. Here will be another junction. So, let us solve for the single junction, this will be replicated at every junction. So, cross sectional area of this tube is AK, this tube is AK plus 1. Here, so volume velocity in here which will travel along the tube forward wave, this is nothing but a ut plus, or you can say uk t, and here it is nothing but a uk plus Lk t. Backward wave in here, it is nothing but a uk minus Lkt, and here it is nothing but a uk minus t. Input of this tube here, forward wave is nothing but a uk plus 1 t. Backward wave in here, it is nothing but a u plus uk plus 1 minus t. If it is the end of the tube in here, then it will be uk plus 1 plus Lk plus 1 t, and here will be uk plus 1 minus Lk plus 1 t. Length of the tube is Lk plus 1, here is Lk. Okay. Now, what will happen if you see the slides? I had tau k. So, here I have written as a tau k. Why, what do you mean by tau k? If it is see, this is nothing but a uk plus t minus tau k, where tau k is nothing but a Lk by c. Okay. Here it is k plus 1 t, here again it will be this will be nothing but a uk plus 1 t minus tau k plus 1, where tau k plus 1 is nothing but a tau k plus 1 is nothing but a L k plus 1 divided by c. Okay. Backward wave same, I can say the backward wave like this way. Okay. Now, I have to know what happening in the junction. This junction, what is happening? What will happen in this junction? Okay. So, this junction, what will happen? Some I have to find out some. So, if you see that if this is analogous to the water pipe also, suppose there is a pipe, water pipe, different cross sectional area water pipe are joined together. So, the water is flowing here, some of the water if you this junction. So, the volume velocity this point is the volume velocity which is injected in the second tube, and the backward volume velocity in the kth tube is nothing but a volume velocity which is injected due to the backward wave. So, I have to find out the expression of the forward wave of the kth plus 1 tube and backward wave at the kth tube. If I am able to find out these two expression, then I know what will happen in the junction. I can draw the equivalent signal flow diagram at the junction. So, my whole purpose is to find out how much forward wave is injected by the kth tube to the kth plus 1 tube, and how much backward wave is injected by kth plus 1 tube to the kth tube. That I have to find out. So, I want to know the expression of uk minus t plus tau k, this is t plus tau k, this one, and I want to find out uk plus 1 t, 1 uk plus, these two expression I want to find out. Okay. Now, what is the problem? How do I find out that things? Okay. So, how do I find out? Okay. So, let us start that expression, how to find out these two equations. How to find out? So, I can say that uk plus 1 x t, any point uk plus 1 x t is nothing but a uk plus 1 plus t minus uk plus 1 minus t. What is x t? At x equal to 0. So, this will be 0 t. Okay. u k plus 1, or I can say P pressure wave P k plus 1 0 t is nothing but a z k plus 1 u k plus 1 plus t plus u k plus 1 minus t at x equal to 0 at the k plus 1 tube. At x equal to L at the kth tube u k plus u k at L k t, end of the kth tube u k L k t is nothing but a u k plus t minus tau k, where tau k is L k by c, minus u k minus t plus tau k, okay or not. And P k L k t is nothing but a z k into u k plus t minus tau k plus u k minus t plus tau k. Okay, where z k plus 1 is nothing but a rho c by a k plus 1 and z k is nothing but a rho c by a k. Cross sectional area of the tube is a k, okay or not. Okay. So, I am not animation, I am not showing the animation. This is the 1, 2, 3, 4 equation I will get. I know what I have to find out. I know I have to find out u k plus t plus tau k and u k plus t. This I have to find out. This is the 4 equation I get. Okay. Now, if I say this one is equal to this one, okay or not. The volume velocity which will input to the second tube is nothing but a volume velocity which is exited from the first tube. So, the volume velocity which is exited from the kth tube will be the volume velocity which is the input of the k plus 1 tube. So, I can say u kth tube volume output volume velocity is nothing but a u k plus t minus tau k minus u k minus t plus tau k, which is equal to the volume velocity input of the k plus 1 t. So, it is nothing but a u k plus 1 plus t minus u k plus 1 minus. Is okay or not? Okay. Second one is that output pressure of the kth tube will be equivalent to the input pressure of the k plus 1 tube. Okay. So, what is output pressure of the kth tube? Z k u k plus 1 t minus tau k plus u k minus t plus tau k, which will be equivalent to or equal to z k plus 1 u k plus 1 plus u k plus 1 minus t. These are two equations I will get from the condition. So, I said that if it is the my first tube and if it is the kth tube and if it is the k plus 1 tube, red one is the k plus 1 tube. So, the volume velocity which is inject at the output of the kth tube will be the equal volume velocity at the input of the red tube. Similarly, the output pressure of the black tube is equivalent to the input pressure of the red tube. That is why I make. Okay. If it is that, then can I solve these two equation for these two? I have to find out u k plus t and u k plus 1 t and u k minus t plus tau k. The amount of expression for the reflected backward wave at the kth tube, expression for the forward wave k plus 1 tube. These two things I have to deduce from these two equations. Okay. Now, if I take this one, okay, then I can say that this using these two equations I can find out the expression. I am not deriving, you can derive it and find out the expression. So, the expression of u k plus 1 plus t will be 2 z k divided by z k plus z k plus 1 u k plus t minus tau k plus z k minus z k plus 1 divided by z k plus z k plus 1 u k plus 1 minus t. Okay. And u k minus t plus tau k will be minus z k plus z k plus 1 divided by z k plus z k plus 1 into u k plus t minus tau k plus 2 z k plus 1 divided by z k plus z k plus 1 into u k plus 1 minus t. This is the two expression I will get from these two equations. Okay. Now, just try to simplify these two equations. So, what I can write, that if I write R k is nothing but a z k minus z k plus 1 divided by z k plus z k plus 1, z k minus z k plus 1 divided by z k plus z k minus is nothing but a R k. If this is R k, then I can say this expression u k plus 1 u k plus 1 plus t forward wave at the second tube will be, or k plus 1 tube will be nothing but a 1 plus R k, this is small r k. So, this is 1 plus R k into u k plus t minus tau k plus R k u k minus k plus 1 minus t, and u k minus t plus tau k will be equal to minus R k, this one minus R k into u k plus t minus tau k plus 1 minus R k into u k plus 1 minus t. Okay. Now, try to draw the diagram at the junction point. So, I want to draw the diagram at the junction point from these two equations. Let us try in here also, here only, so that it will be little bit of equation are there. Okay. So, now what I said, I want to know, this is the junction, this is the 4 point at the junction. This is nothing but a u k plus 1 plus t, and this is going this direction, and backward wave is going this direction at the junction. So, it is nothing but a u k minus t plus tau k. Okay. So, signal flow I can say this direction, this is the forward direction and this is the backward direction. So, this is nothing but a u k plus t minus tau k, and this is nothing but a u k plus 1 minus t. So, I can say u k plus or u k plus 1 t, this is nothing but a 1 plus r k into, so this signal multiply by 1 plus r k, and it has to be go a signal from here which has to be added there, which is nothing but a multiply by r k. Okay or not? Then I want to know this signal. This signal is nothing but a here which is there u k plus t minus tau k has to be multiplied by minus r k, and this signal u k plus 1 t minus has to be multiplied by 1 minus r k. I get the junction diagram. So, if you see that this is the junction diagram I have drawn in here. So, once I know these two equation, I know the junction diagram, 1 plus r k, 1 minus r k. Okay. Then what is r k? R k is called reflection coefficient. How it is come? What is z k? Rho c by a k, rho c by a k minus rho c by a k plus 1 cross sectional area of the a k kth tube, cross sectional area of the k plus 1 tube minus rho c by a k plus rho c by a k plus 1. If I evaluate it, it is nothing but a k plus 1 minus a k divided by a k plus 1 plus a k. Okay or not? So, this is called, that is why r k is called reflection coefficient. R k is called reflection coefficient. It is nothing but a cross sectional area of k plus 1 tube minus cross sectional area of the kth tube divided by the cross sectional area of the k plus 1 tube plus cross sectional area of the kth tube. Okay. So, the diagram, so kth tube length is L k, so delay is tau k. So, I can say whole diagram, so kth tube length is L k, so delay will be only tau k, here also will be delay tau k, and here is I get the input of the kth tube, which is nothing but a u k plus t and u minus k t. Here is the delay of the k plus 1 tube tau k plus 1, and here will be delay of the k plus 1 tube tau k plus 1, and I can get that u k plus 1 plus t minus tau k plus 1, and here I get u k plus 1 minus t plus tau k plus 1. So, this is the complete junction signal flow diagram. Think about similar kind of junction is repeated, instead of k I can say put 1, k varies from 1 to let us n. So, if there is a n number of tube, then I can say k varies from 0 to n minus 1 tube, k varies from 0 to n minus 1 tube. Okay. Now, I just consider the value of what should be the value of r k. The r k is a k plus 1 minus a k divided by a k plus 1 plus a k. Now, what is the maximum value of r k? What is the maximum value will be of r k? What is the minimum value of r k? If a k is very small compared to a k plus 1, if I neglect a k, then r k will be 1. If a k is very big compared to the a k plus 1, or if a k is much greater than a k plus 1, then I can say r k will be minus 1. So, if the cross sectional area of the second tube is larger, much larger than the first tube, at the junction R k reflection coefficient will be plus 1. Okay. If A k is less, A k is much greater than A k plus 1, then R k is minus 1. If A k plus 1 is much greater than A k, then R k is plus 1. Okay. So, this is 1 minus R k. If R k is plus 1, then if you see this signal reflected, the backward wave is multiplied by this backward wave, effect of backward wave is multiplied by 0. Okay. If it is R k is minus 1, then 1 minus R k is positive. Okay. So, minus 1 2. So, this is the maximum value of R k will be either plus 1 and minus 1. So, you can prove it that R k value maximum value will be plus 1 or minus 1. Now, suppose I have a case n number of tube with equal length. If I consider all tubes are equal length, then what should be the diagram? So, I said this delay tau k is equal to tau k plus 1. If all tube length are, so what is tau k? L k by C. So, if all tube length are same, then I can say the tau k is equal to tau k plus 1, all are del x, del x, del x, del x, del x. So, delay circuit will be same. So, it is nothing but a delay will be same delay will be happen. Now, if it is that, then I can say let us tau is equal to sampling period T 1. Z to the power minus 1 is one sample delay. What is the delay? If it is 8 kilohertz, then what sampling period? 1 by 8 kilohertz is the sampling period. So, sampling period delay will be happen. Let the tau T 1 sampling period is equal to tau. So, this is one sample delay in here. So, I can say this is replaced by Z to the power minus 1. So, if it is tau k is the delay, so tau k delay is replaced by Z to the power minus 1, and what tau k is equal to tau k plus 1 is equal to tau, and this tau is equal nothing but a sampling period is equal to sampling period. So, in that case I can say the signal is one sample delay, that is Z to the power minus 1. Now, considering the boundary condition, I can derive the complete transfer function of this tube model in Z domain, then I can implement it. Okay. So, next class what I want to do, I want to derive the total vocal cord transfer function for a n such tube model, So, instead of you can say the single tube, I consider multiple tube of different cross sectional area are conjuncted with each other. Let there is a n number of tube, then I derive the signal flow diagram for the single junction. The same junction will be repeated for n minus. So, if there is a n tube, n minus 1 junction will be there. So, n minus 1 junction will be there in the tube, this will be repeated. Then I can say the delay can be simply implemented by sampling delay. So, if I replace this tau k delay by Z to the power minus 1 sample delay, then I have to find out the whole Z domain equation of this vocal tract transfer function. So, next class I will try to do that. Okay. Thank you.